calculating the degrees of freedom. Even in the chi-square, we take care of the degrees of freedom into consideration. The number of rows minus 1 into number of columns into minus 1. It's a 2 by 2 matrix, right? 2 minus 1 into 2 minus 1, that is 1. Now, if we calculate the p-value, we need to look at the chi-square table even to get the p-value. P is nothing but the probability. Is nothing but the area under the curve in chi-square. This is the chi-square value and this is the degrees of freedom. At this, the overall p-value is this much, 0.001. There is a 0 point, but what do you interpret based out of this value of the p-value? Because we are always making p-value as an objective figure to interpret the results. But what is it interpreting? There is 0.001 chance of obtaining such discrepancies between expected values and observed values. That means if there is no association, right? That means this chance of getting the discrepancy between the expected value and observed value. What is the expected value? You are making use of certain methodology to predict the values of the people who could get deceased. Right? You're calculating the proportions. You're multiplying the deceased people with the proportions to see how many of them are exposed, actually not exposed. That's a methodology you're following. But what this p-value is saying is, so because of this methodology, the discrepancy between the expected values and observed values is very negligible. That means there is a true association existing between exposing towards the radiation and people are getting disease. And this is how the chi-square test works. You're not going to use this anywhere. Don't worry too much. Just to let you guys know, because some of the interviewers, just to prove themselves that they are more talented, they would be asking some questions which may not be using in the real time, right? For that purpose, we have discussed how ANOVA works internally, how chi-square test works. So with this, we are done with basic statistics. So any questions, guys, before I move forward? What is that we are going to learn? As part of data mining, we are going to discuss about broadly two classifications, two categories. One is supervised learning. And the next one is unsupervised learning. Right? Supervised learning is also referred as machine learning. When do we go for supervised learning? When do we go for unsupervised learning? If you know the output variable, what we are predicting, then y is known. I'm not talking about the value of the y. I'm talking about which variable you are predicting. When y is known, then you go for supervised learning. When y is unknown, go for unsupervised learning. Clear? So as part of supervised learning, we're going to learn two broad categorizations again. One is regression problems. Second one is classification problems. As part of regression, we'll be discussing about linear regression. And logistic regression. And as part of classification, we'll be discussing about naive Bayes algorithm, k nearest neighbors, decision trees, random forest, bagging and boosting, XGB, LGBM, gradient boosting, light gradient boosting. Right? And along with the regression, we will also look at lasso regression and ridge regression, which are more effective methods of effective algorithms for building the models, predicting the regression problems. Okay, lasso and ridge. It doesn't mean that we'll also discuss about neural networks, artificial neural networks, ANNs. It doesn't mean that we'll make use of all these algorithms just to solve the classification problem. We can use decision trees, random forest, XGB, LGBM, neural networks for solving both regression problems as well as classification problems. What are regression problems and what are classification? When the variable y, which you are predicting, is continuous, you go for linear regression. When y is discrete, or categorical, you go for logistic regression or any of these classification algorithms. And as part of unsupervised learning, we will be discussing about clustering, which are nothing but we will discuss about two different techniques here: hierarchical clustering and k-means clustering. The next we are going to discuss about dimension reductions. Dimension reduction. Here we are going to discuss about PCA, principal component analysis. This is one of the dimension reduction techniques. Next, we will look at association rules or relationship mining. And post which, we will discuss recommendation systems. Finally, as part of unsupervised learning, we'll deal with text mining, which is analyzing the unstructured data. Right? And once we are done with all this, then we will be discussing about time series forecast. This is not part of either supervised learning or unsupervised learning. And the sequence in which we are going to look at this. First, we will look into linear regression, logistic regression, and different flavors of these regressions. In linear regression, we will look into simple linear regression, multiple linear regression. Logistic regression, we will look into binomial logistic regression, multinomial logistic regression. Post which, we'll get into clustering and we'll complete all this unsupervised learning. And after that, we'll come back to supervised learning and start with the classification techniques. And we will discuss lasso and ridge regression, and after that, we'll start with the classification. Once we are done with this, finally, we will be discussing about time series forecast. Am I clear? So this is what we're going to learn for next how many weeks? How many weeks we are done with so far? We're done with 1, 2, 3, 4, 5, 6. 3 weeks, including this today's class, we are done with 3 weeks. It is just 6 sessions. We will be spending another 7 weeks time. 7 2s are 14 sessions, right? And this is what we're going to learn for next 7 weeks. And I would recommend you guys to start attending the assignments. With this, we are done with basic statistics. You can solve all the assignments that are part of your basic stats assignments. Spend some time in going through the videos, right? And start attempting the assignments. Only then you will be able to remember what we discussed. You just close the books, and if you don't revise the videos till you come back next week, there is no point in doing this. Just spend quality time for next 4 to 5 months. For the next 10 to 15 years of your career will be taken care. Okay. Okay, guys. So I'd like to stop here for today. We'll meet next Saturday at 2 p.m. We'll start with machine learning next week. Okay. Online folks. Okay, guys. Thanks for attending. We'll meet next Saturday. Thank you.